Okay, looking at rule 3 of indices then. Rule 3 of indices is if you do a power to a power, then you multiply your power. So a to the power of m, all to the power of m, is a to the power of m times n. I'm just going to prove this one for you to begin with. We've got 3 squared, all to the power of 4. That means we've got 3 squared times 3 squared times 3 squared times 3 squared. Now using the rule that we had previously, when you're multiplying you add your powers. My base stays as 3. We're adding 2, 4, 6, 8. We get 3 to the power of 8 and 2 times 4 is 8. Okay, so if you ever get confused about this one, if you ever forget it, you can write it out in full. Question 2 then, we've got x to the power of 3 all to the power of 2. 3 times 2, oh, don't know what I did there, is x to the power of 6. Number 3, we've got x to the power of 4 all to the power of 5. 4 times 5, 20. Okay. Number 4, we've got a number in front, it's like 2x to the power of 6 all squared. I'll just put this one out in full just to show you. We need to raise both parts of that to the power of 2. So we're going to do 2 squared and x to the power of 6 squared. So it's 2x to the 6 times 2x to the 6. 2 times 2 is 4. X is my base. 6 plus 6 is 12. Okay, without writing this one out in full, what we're really doing is squaring both parts. We're doing 2 squared and x to the power of 6 squared. 2 squared means 2 times 2, which is 4. X to the 6 all squared is x to the power of 12. Number 5, we've got 3x to the power of 5 all to the power of 3. Now 3 to the power of 3 is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So we get 27x to the power of 5 times 3 is 15. So we get 27x to the power of 15. Okay, some for you to try then. So try questions 3 and 4 from here. Again, you might want to pause the video at this point and just practice these ones, but I'm going to continue on and look at the next rule. Okay. Question 5, there is a mixture of everything. Feel free to try that one as well. Now, rule number 4 is a simple one, as long as you remember it. Okay, rule number 4 is that anything at all to the power of 0 is 1. Okay, so 325 to the power of 0 would be 1. 3x to the power of 5 all to the power of 0 is 1. X to the power of 5 times x to the power of minus 5. When we're multiplying, we add our powers. 5 add minus 5 is 0. And x to the power of 0 is 1. Okay, some for you to try. I'll leave you to guess what all the answers here are. And again, I'm going to continue on, but you might want to pause the video here and try these questions. Okay, rule number 5 is looking at negative powers. So if you have a negative power, you can rewrite that as a fraction. So a to the power of negative m is the same as 1 over a to the m. Okay, so if we look at number 1, if we've got 3 to the power of negative 4, we can rewrite that as 1 over 3 to the power of 4. Number 2, a to the minus 7, so I can write that as 1 over a to the power of 7. Number 3, we're multiplying, so we add our powers. Minus 9 add 4 is x to the power of minus 5. I want to rewrite that with a positive power to be 1 over x to the power of 5. Okay, some for you to try then. So try question 7. Okay, or these ones at the end, same idea, we just do it the opposite way. So instead of writing it down and making it negative, we bring it up and make it positive. So 1 over x to the minus 3 is the same as x to the power of 3. That should let you answer the last few questions then. Okay, the last rule then is looking at fractional powers. So if we've got, I don't know why my lines disappeared there, we've got a to the power of m over n, that's the same as the nth root of a to the power of m. For example, if we've got 16 to the power of 2/3, that's the same as the cubed root of 16 squared. Okay, my lines all seem to have disappeared from my fractions here. If we've got x to the power of 4/5, that's the fifth root of x to the power of 4. Find this one a wee bit trickier, but I've heard a few things. Okay, roots go at the bottom. Power at the top. So the bit that's your power, the bit that's going to be the power for the base, the same way as every other power has been written, is the number at the top. The root number, the one that goes on the square root sign, or on the root sign, because it's not a square root unless there is no number there at all, or a 2, is the number at the bottom. So that might help you get those ones in the correct order. Number 2, we're going to rewrite these with a fractional power, so it's the same idea, just doing it the other way around. So it's x to the power of, and we need to decide whether it's 6/7 or 7/6. So the power goes at the top, so it'll be 7/6. B, same idea, want to rewrite it with a fractional power, the power goes at the top, so it'll be 2/3. Okay, let me just pause this and get my calculator ready for the next bit. Now, like I've said before, you can use your calculator for any part of this that you like. Now, normally teaching this, I'd be teaching it without a calculator, so we'll show you it without a calculator, but you can use your calculator, and I will show you how to put it into your calculator as well, but you will need a scientific calculator in order to put this into your calculator. Okay, 16 to the power of a half, put that into square root form, I get 16, I get 2 there, and a 1 there. But is actually just the square root of 16. I don't need to have the 2 and the 1 there, they are essentially invisible when we're dealing with square roots. So the square root of 16 means that you're looking for a number that times by itself gives you 16, which is 4. You can use the square root button, and that gives you your 4. But you can also put it in this form here. Okay, so we've got 16, and then the power of button. Now we've used our power of button before, not the times 10 to the power of x button, the power of button. So it's this one here, the x with the box. And I want to put my fraction in. So I press my fraction button, and it goes in as a half, which gives me my 4. Part B, 64 to the power of 2/3 is the same as the cubed root of 6. I don't know where 3 came from. Cubed root of 64 squared. Okay, so without your calculator then you're thinking of a number that times by itself 3 times gives you 64. With your calculator you should have above your square root button a cubed root button. Okay, so you can type it in from there. So that would give you 4. We still need to square it, so we get 16. But again, if you get yourself a calculator and you learn how to use it, we could do 64 to the power of 2/3. And that gets me my 16 straight away. See, we've got the cubed root of 125 squared. Cubed root means we're looking for a number times by itself 3 times, gives me 125. That's going to be 5, because 5 times 5 is 25, times 5 is 125. Still need to square it. So I get 25. Using our calculator. Now you can use your calculator if we use this button here. So I'll do that again. Press Shift and then a power of button. I can put this in exactly as it is. So the cubed root of 125 squared gets me straight to my 25. Okay, last one then, we've got the fourth root of 16 cubed. Fourth root is the square root and a square root again. So square root of 16 is 4, square root of 4 is 2. So we're doing 2 cubed, which is 8. On our calculator, we're doing the fourth root of 16 to the power of 3, which is 8. Okay, I'll leave you to try some of these. These ones are the tricky ones. Okay, so try question 12 and question 13, and then there's also a question 10 here. I've just done it in a slightly different order from the booklet. These are the evaluating ones. Okay, so get your calculator working on these. Make sure you're getting used to typing it in. Okay, I'll do another video for the last wee bit on indices.